number 9.
Yes.
The roots of the equation.
Mm.
The roots of the equation x squared plus 6x plus q is equal to 0 are alpha and alpha minus 1. Find the value of q.
So we are finding the value of q.
Yes.
Okay, so what did we say sum of roots is equal to?
Sum of roots is equal to 6.
Is equal to
So
6.
negative 6.
Negative 6.
Mm.
Yes, so here we are going to add alpha.
Isn't it negative?
Yeah, it is negative. I've put it there. So we are going to say sum of roots is alpha plus alpha minus 1. Okay? And this is going to be equal to negative 6. So alpha plus alpha is 2 alpha minus 1 is equal to negative 6. And then 2 alpha is equal to negative 6 plus 1. So what is negative 6 plus 1?
Negative 6 plus 1, that is negative 5.
Negative 5. Then here we divide by 2 and here we divide by 2. And that means alpha is negative 5 divided by 2.
By 2.
Then we as well look at the product of roots. And this is should be C over A. So when we get alpha into alpha minus 1, should be able to give us a what?
Alpha squared minus alpha.
Okay, but this is equal to Q, okay? So this would be alpha squared minus alpha, which is equal to Q. But we already have the value of alpha, okay? Which is the negative 5 divided by 2. So we square this, then we minus negative 5 divided by 2. And this would be equal to negative Q. So this would be 25 over 4. Then we add, because this negative is followed by negative, so we add 5 divided by 2. So, and then from here we can substitute in a calculator and then get the value of Q.
Q, we are getting 35 over 4.
35 over 4. So that is how it is done.
How was Q come up with? How have you come up with this Q?
And the Q, I've used the like the way we say product. So product of roots is equal to C over A. So here C is what? Is Q. B is 6. And then A is 1. Okay. So remember here we have said sum of roots is equal to negative 6. So we have used the formula negative B over A. Isn't it so? And then yes. for product, we still use the formula C over what? C over A. But the value of C is Q, and then the value of A is a 1. So when we divide, Q divided by 1, it gives us a what? A 1.
Then the next question. The next question is the roots of the equation. X squared minus px plus 8 is equal to 0 are alpha and alpha plus 2. Find the two possible values of p.
we
the
find
the
the
two
two
possible
possible
values
values. So we are going to still use the same knowledge, okay? So we are going to find sum of roots, and it is equal to negative b divided by a, okay? Now the sum of
the sum of roots is equal to negative p over
okay. This case it is going to be alpha, then plus alpha plus 2 give us negative of negative p. So 2 alpha plus 2 is equal to
positive p.
to p. Okay, so here we shall call this equation 1, okay?
Yes.
And then we also get product roots. So this will be alpha, 2 alpha plus 2, and this will be equal to 8. Okay, so when we open brackets here, we shall have alpha squared plus 2 alpha is equal to 8. And then here we can say, so since it is alpha squared, so since it is a square, it is going to become a quadratic equation. So we bring the 8 to the left hand side, so it becomes minus 8 is equal to 0. Then we are going to get two factors that we add to give us 2, and when we multiply them, they give us negative 8. So what could those numbers be?
Negative 2 and positive 4.
So 4 and negative 2. So we say alpha squared plus 4 minus 2 minus 8 is equal to 0. Then we group them. So alpha squared plus 4 alpha, then minus 2 alpha plus 8 is equal to 0. So we get a common factor here,
which is alpha squared.
Which is alpha. Yes. Then we remain with alpha plus 4. Then we get another common factor in the second bracket,
which is 2.
Which is 2.
We get alpha
plus 4. And then here we shall have alpha minus 2, 2 alpha plus 4. This will give us a what? A 0. So we say either alpha minus 2 is equal to 0, and alpha here is 2, or alpha plus 4 is equal to 0, and then our alpha is equal to 4. So, but remember our negative 4.
Negative 4, yes.
Yes, remember our P is 2 alpha plus 2. Okay. So when alpha is 2, P will be 2 times 2 plus 2. And that gives us
6.
6. Then when alpha is negative 4, our P would be 2 times negative 4 plus 2. Then what would
-8 plus. Our answer will be -6.
P would be -6. Okay.
So teacher, the other one, you mean it was just a formula where you on the sum of roots, where
Yes.
we are doing like negative b over a.
Yes, it is a
So,
formula.
uh-huh.
This one here.
So
This one.
if you are
This.
an exam,
Mm.
teacher, if you are in an exam, then you list like that.
Yes.
Can't you be marked wrong? Because
No.
if it is, if b negative b over a is not the sum of roots, after all, the sum of roots is negative p. So how
Okay.
how will you come to that?
You can first state it and then later state this procedure. Okay. Because if like if you don't state it, you might forget this negative sign when you are answering here, and then it might make your answers wrong. Okay. But if you have done enough practice and you feel there is no need of you writing it, then you may ignore, but it is okay if you write it. So you can say the formula for sum of roots is equal to negative b over a, and then you substitute in it. Yes.
Go to the next question.
Okay.
Proof. I have this question.
It says
I'm still looking for it. So
It's okay.
prove that, teacher, the question is prove that if the sum of the squares of roots of the equation is
sum of the squares
of the roots of the equation is a squared plus bx ax squared plus bx plus c is equal to 0 is 1, then b squared is equal to 2ac plus a squared. So teacher, that is the question.
then b
squared is equal to 2ac plus a squared.
So we are saying prove that if the sum of the squares of the roots of the equation that is 1. So sum of the squares. So if we let our roots to be alpha and beta, then we are saying the sum of the squares, okay? Alpha squared plus beta is equal to
Beta squared.
1, okay? Prove that if the sum of the squares of the roots, this is equal to 1, then b squared that is equal to We are going to begin by saying this can be obtained, which is on the left-hand side, by expanding alpha plus beta squared, which gives us alpha squared plus 2 alpha beta, then plus beta squared. So alpha plus beta squared is equal to, so we bring these ones closer to each other, then 2 alpha beta. So from there we can say alpha squared, okay, plus beta squared is equal to alpha plus beta squared minus 2 alpha beta. Are we there? Then we can say now if there are the roots up here, what would be? So if our equation is ax squared plus bx plus c equaling to 0, so what is alpha plus beta?
Alpha plus beta is negative b
Over a.
over a, yes, negative.
Then alpha beta is c divided by
C over
a. Okay. So we are now going to substitute in this equation. So instead of alpha squared plus beta squared, we are going to write this, which is alpha plus beta squared minus 2 alpha beta, and we put that to 1. So we are going to say negative b over a squared minus 2 times c over a is equal to 1. Are we there? So when we expand negative b over a squared, we shall have b squared over a squared, then minus 2c over a. So this would be b squared over a squared minus 2c over a, and this is equal to, so we can find LCM here, which is a squared. This will remain as b squared minus 2ac, and we put this to 1. Are we there?
yes.
And then after we can cross multiply here, then we have b squared minus 2ac equaling to a squared. Are we there?
Yes.
So what had we wanted at first? What are we proving? That b squared is equal to?
We are proving that that b squared is equal to 2ac plus a squared.
Okay, so we just take this one to this other side, so that we have b squared equaling to a squared plus 2ac.
2ac.
Yes. And we would get done. So it is just a matter of playing around with the sum and product of the quadratic equation.
Teacher, there was a question here I had in this textbook of mine.
Yes.
There were questions I was attempting,
okay,
but they happened to confuse me. So they are the ones that I'm looking for here.
Okay. Let me first stop.